it's like a kind of very metallic-y kind of like cutting sound.
Yeah, but you can understand me or not at all.
Good evening, good afternoon, wherever you happen to be.
Hello.
Hello,
Hi,
how do you do? Good to see
Hi.
you.
Yeah, Michael, I can hear you fine, but Jan is. Can you hear him okay?
No, I'm getting some compression artifacts.
That's what it is,
Yeah.
Is
compression
the
artifacts.
as worse as it was last time?
Yeah, it does sound a lot like that.
Is that
What's
Yeah.
the try something? What's the latency are we talking here? Because I think are you all in Europe, like London-ish, or
Well, I'm in the United States, and Jana's in France.
oh, I guess we got an international
Yep.
thing connecting over here. I myself am in Toronto, Canada. So
Awesome. Yeah, we've had folks visiting from all over the globe. Yeah, I'm pretty pleased that we've been able to attract an international audience. So I'm thinking
cool.
that we'll probably have to have another session if things start to get to get more popular, so that we can cover Australia, because I think this time zone is pretty bad for Australia right now. But
yeah. Well, wherever you hit a spot and there's a good niche of
Yeah.
people kind of resonating with the book. I don't know, how do you all do this? So is there like an agenda, or you just jump in?
Yeah, so we had an agenda at first when we when we first got started. There were a whole bunch of folks that were just going through the book, and so I kind of set an agenda where we talked about a couple of chapters each week. But then since then, we've been using this time for meeting new people who've been introduced to the book, and just wherever they happen to be along that path, and also talking about open source projects that are in support of the ideas presented in the book.
Yeah, the Janaga, or is that how you pronounce it?
Yes, yeah, exactly.
Got it.
Yep.
Michael, is the sound better like this or not at all?
Yeah, that sounds better.
It's better for
Okay,
sure.
it's understandable this way.
Yes.
Okay.
Oh, okay. So it wasn't a network latency issue then, apparently.
No, today I'm on the fastest connection I've ever been. It's a good fiber connection, and I'm wired, so no Wi-Fi. But I'm on a very old laptop, which is Atom based. So I think that might be the problem. I have only two old netbooks with me. That's all I have. So the video is fine, but the audio is giving trouble apparently.
No, so far right now it's better.
Yeah, indeed.
Okay.
Yeah.
No,
Michael, it's really wonderful that there is a Discord for this book, and I've been thank you so much for replying to the questions I had. So I did end up finishing the book by the time we finally managed to join the Discord chat. And do you get a big cut from each sale of the book, or is there like another way to just send you money? Because I borrowed the book from a friend, and I want to like kind of make my contribution.
Yeah, honestly, what I'm trying to get out of it is to build a community, and so that's what the Discord is about as well. If you want to support me financially, one thing you can do is watch my Pluralsight courses. That might be something else that would give you some value, and also.
Okay, cool. Yeah. Sounds good. I was just worried if the book publisher takes like 70% or something, and it's like sometimes in academic publishing that's the case.
Yeah. I didn't write it to become rich, that's for sure.
And Sergei, a subscription on Pluralsight is not lost. It's not only Michael who is there. There are also good authors on Pluralsight.
Nice.
Got it.
Oh, that's a joke.
What's the website that this course is on?
Pluralsight.com. as in
Plural site.
multiple site. Yeah.
Yeah, got it. Thank you.
Thank
I
you.
think like the most burning question I had, kind of having read more of the book, is and where this touches on with these ideas of I keep posting about this thing called pseudo time and like the transactions. I think what's interesting to me about the this book's approach is like very extreme, and like I like it in that it's very daring, right? Because you're like, okay, it's a DAG, like every
Yeah.
fact and every relationship is so explicit. I think what kind of, here's the scenario that like kind of I'm thinking about. Um, Imagine an interface where you see a lot of information, like say it's a patient chart or a business loan application or something like that. So there is a lot of information about a person. There's a comment thread, and all that. And so this actor, like a physician or a person or something, looks at all that and then posts a note, just like a little text note. From a timeline perspective, like I think for the sake of ordering the nodes, you could imagine that like, well, the predecessor of that node is the like the one node before it, logically speaking, or the most bottommost node, just so that there is a kind of thing. But on the other hand, isn't technically every fact that went into the making of that page technically a predecessor of that note, because the person saw all of that when they made the note? So
Yeah.
that sounds to me like a explosion of predecessors.
Yeah. Yeah, and I would definitely not want to model the application like that, so that you actually did capture as a direct predecessor everything that the user saw at the time they made the note. So I would say that predecessor, as it is represented in the DAG, that's the important predecessors. That's, this decision doesn't make any sense without knowledge of these prior facts, as opposed to the more loose definition of this was everything that the user knew at the time they made this decision. It's just some of that information, according to the model design, was irrelevant. Now, if it actually turns out that it is relevant to your model, then yes, you'll want to capture that as a predecessor node. But then, how do you avoid the explosion? And so then I think and it's all based on your model. It's based on your decisions as an application designer. You can make the decision to include a local machine timestamp within the fact, and now you have to understand the consequences of that choice. One, no other machine is going to honor that timestamp as strict ordering. They're not going to trust that your clock is in sync with theirs. And the other thing is that you'll have to recognize that things that are causally unrelated could still come in before or after, even if they have an earlier or later timestamp. So there's no constraint there. And the third thing, probably the most important thing to recognize, is that timestamp now becomes part of the identity of that fact. So if it's important for two people to be able to say the same thing and be the same fact, then you don't want to include the timestamp.
And got it. Yeah, I think that's the issue when you say that like some predecessors are more important than others. Like it feels like there's something there, because I could depending on application, I think that distinction could be pretty fuzzy. Like in that David Reed paper, for example, one of their kind of motivating examples was you go through a directory of employees looking at salaries. And then you say you want to make the average, you want to give basically one regional office a office-wide bump in salary to make it equal to the other one. So his kind of scenario is that every kind of salary that you've read is part of that transaction going in, because that's what going into the calculation.
Mhm.
So therefore, whereas in this case, you would model that as, yeah, all of those are predecessors of the new facts. Would that be fair to say?
Yeah, which could lead you to a graph that has a wide set of nodes, all predecessors to another set of nodes, and so everything points to everything else in
Yeah.
kind of layers. So it might be better to consolidate that causality, and that's one of the ways that I use the period pattern. So so if you just have a fact that represents first quarter of 2021, and then another one that represents second quarter of 2021, now you can have your other facts related to those, and you can see, well, what was the salary as of this period, and then if I create a salary change, it's going to be related to a certain period, and so it takes effect in that period, and you can organize it that way. And then the advantage that has on the graph is that those periods aren't causally related to one another. So you don't have a chain of each period pointing back to its prior one. Now it's part of the application's understanding of, I know as an application designer that Q2 comes after Q1. And so you don't have to represent that within the graph. And that keeps the graph nice and shallow, and it also keeps the number of predecessors per fact lower.
I think I follow. Yeah. So the period pattern is crucial for. I guess in this case, you would try to basically align. So it's kind of like a bucketing thing. You're bucketing all these salaries into a period. Though I guess, like, if somebody's salary was updated at a certain time, but somebody else's was updated at a different time in a different period, but at today they both have that's the salary we're looking at, even though they are in different periods. So it's like now you have to look at multiple periods.
Yeah. So you do always end up, when you're using the period pattern, looking at multiple periods. So yeah, you usually have a.
Is it because they kind of pyramid up, like hours add up into a day period, days add up into a month period? Is that the idea?
Sometimes. I will sometimes have maybe two levels of hierarchy. I usually don't need any more than that. So it might be like a quarter in a month, or maybe a year and a month. But that's all based on the problem domain. Like if it's accounting, accountants like to work in quarters. So that's an important bookmark for them, or a boundary for them. But the reason that you often query multiple periods is that when you reach a boundary, if you were to stop querying one period and just start looking at the current one, then all of this history just disappears from your view. So I usually have like if I'm
you need it's a rolling kind of 3 periods or something.
Yeah, 3 is usually a good number.
Window.
Hey, Sergei, but is it important for you to know the causality between the salary raise of one employee and the other one?
Well, that's what's interesting about this motivating example. And I actually, when I saw it initially in that paper, which I think I linked in the Discord channel, I thought of it as I thought it was an interesting kind of a ambitious example, because he was going kind of beyond CRUD, like read everybody and update separately. He was phrasing it as a single kind of coherent transaction that like defines its rules for, at a moment of time, all these people will, like, their salaries will be calculated, 2 averages will be computed, and then a bump will be applied to all the relevant things, and that's a single atomic change, which sounds like a huge lock over like hundreds of rows, but I guess the approach proposed is that it's done through some sort of a scheme that doesn't necessitate locking. I think it's because it's very MVCC like, in that versions of records are retained, so that another transaction that's just like reading an old row can continue reading an old version or something. But to bring it back to the example, the causality I think is there in that the idea is there was a single decision at a single like logical point of time where for all these things we're going to gather up their salaries, make a calculation, and apply it to say n over 2, like half of them. So I don't know, in terms of causality, yeah, does that sound like, to me that sounds like everybody who was read into that calculation is a predecessor of everybody who was updated.
Yeah, but Michael, can we not, instead of having the salary as a fact, just keep the fact that there was a salary raise with all the people to who the salary raise applies?
All right, and then you have to gather that raise fact when you're asking the question, how much do I actually pay this person right now? You have a query that gets those successors, and then does the calculation kind of on the fly, rather than the approach that we would just kind of naturally take if we had one SQL database is, like you said, let's lock the entire table, do this big select, update these salary rows, so that way the query can be fast. It can just look it up directly, and this is shifting the idea to let's capture the decision with the least amount of work and information and locking necessary, and then let the interpretation of that decision take place later.
You keep from everybody the start salary, and then the events for increasing linked with a predecessor who has been increased on what date.
Yeah, I think that could work. And so the consequences, which are basically derived from the mathematics of the constraints, the consequences is that at any time that you calculate the salary of a person, you can't know for sure that you've got all of those salary increase events. So you can't run a query that guarantees you get all the successors, and that's basically the overriding constraint that makes historical modeling fit with the constraints of a distributed system in general. So yeah, it sounds like pseudo time is a specific solution that goes beyond the constraints that have built into historical modeling, and so can therefore solve a problem that historical modeling can't solve. And I believe this is a general statement that when you solve a problem that's this constraint of knowing that I've got all the successors, if you solve a problem where that constraint is not sufficient, and so you come up with a solution to give you more information, then you are bringing topology into the problem.
Right.
So like Paxos, you have to know who your neighbors are, who's involved in this conversation, so that you can know when you've got a quorum, using topology to solve problems, perfectly valid. Just you have to know that you're doing it.
I see. Yeah, I do get a little bit of a sense from that paper that the participating nodes sort of play this coordinating kind of game and are able to kind of do a sort of a two-phase lock type of a behavior, even though it's not strictly that, like with less of a locking kind of situation. But I can see how knowing the set of players, so to speak, is important in this situation, because I think if you add a new node that brings in, say that, oh, it turns out there were other employees that you didn't consider, right? So now the kind of the guarantee of what was calculated and its implication isn't, doesn't work because the set of entities has changed. I suppose that is a differentiation in that, like, this was actually something kind of cool about your book, and that, like, the full-hearted embrace of entity not having a home, whereas whereas a lot of systems, I think, would try to say, like, to try to assign even, like, maybe not a physical machine home to an entity, but like at least a logical one. So say, for example, if an entity belongs to michaelperry.com/GUID, right? So yeah, would that ever cause problems? Or, like, is it, in your view, is that still kind of like an undesirable thing, even though, like, that URL can be fulfilled by multiple machines? Like, the topology is not strictly implied. Is there something there, like, as far as logical names for logical homes for entities?
Yeah, I still consider that something to be avoided. So in Chapter 4, location independence, that's one of the location dependent naming mechanisms that I call out, is that a URL it does identify a machine or a group of machines at a particular point in time, and so yes, that URL can be reassigned to different machines, and you can have multiple machines in the cluster. But the fact is, there's a little mix of topology in there, and so I want to completely understand the identity of an object without having to invoke any sort of topology at all, any idea of location. And so, even though I don't really call this out, I would say URIs are on the good side of that equation, where URLs are on the bad side of that equation, and that's usually a distinction that people don't often draw. They just start typing UR, and they see what letter comes next in their API. But
sure.
But yeah, a URI is it's a logical construct that starts with an immutable label at the very least. So the label, I'll start to say michaelperry.net because I actually do own that domain. michaelperry.com is somebody else. But so michaelperry.net is an immutable string. Who it belongs to is not immutable. And so that still has a little bit of the icky in there, is that they can change hands, and then if your data persists over time, then you've got URIs that you aren't technically allowed to use anymore.
Right, but on the gradient of these things, it kind of gets you almost, because you need some sort of a logical namespace for things, like what app are we, what application, what domain are we even talking about? You need some sort of a prefix to say that, this is a UUID of a coffee consumer customer, not a industrial machinery purchaser, right? So it's just different applications altogether. I think that makes sense. The URI distinction is useful.
Yeah, and one of the things that often happens with a historical model is you might start with the idea that you're building an application, and so this database contains all the information about this application, and you quickly run into constraints that kind of force you, very subtly, to switch it to a multi-tenant application. So the facts kind of at the top of the graph, you often find that you need to have a predecessor that's a user, so you have to have a public key somewhere. So that means, okay, somebody actually has to create some kind of identity before they can even start to create the top level identity of the thing. And so now you can have multiple things within the same model, and so you end up in this multi-tenant world. And so one thing that I'll often do when I'm creating a historical model for a website is I will use the domain name of that site as the identifier of one of those top level facts. And so it just naturally supports multi-tenancy. I could host this same site at a different URL, and if I were to detect that coming in, I would be in a completely different part of the database, just because it's a different top level.
Separated.
Yeah.
Yeah, it's interesting. And one thought that came up as we were talking about just now is, the like mobile devices, I can see being a little bit of an influence on this book, because like an impression I got from historical modeling is that it is really cool for that radical topology freedom, that basically a random phone that was offline and creating facts can kind of join others and dump its facts into the system, and it kind of works together even though there were no transactions, kind of like the location independence topology lessness combined does feel quite powerful, which is why I think like personal computing applications to me jumped kind of as a really good use case for historical modeling, because something I've struggled with in personal computing is just that your different apps on different devices at home, in the cloud, and the phone, like they can't all sync. Like it tends to be a disaster because they all overwrite each other and the schemes are difficult. Like if you take, for example, music management as an example, they all disagree about whose database do you keep metadata in. Do you write it to a file here or there? If you swap the folder from under them, they panic and break. Whereas it feels more like a person kind of worst case scenario is, if all your computers got changed, is you are just a pile of hard drives, and there should be sufficient understandability of the record keeping so that you can take all of that, just union it together, and you end up with everything you ever had.
Yeah, indeed. That definitely does speak to some of the the things that I in chapter 12 I talk about kind of the vision of the immutable runtimes and the decision substrate, and that's playing right into that vision. Is that every time I see an application that implements synchronization on its own, it's going to be kind of hit and miss. I look at Google Docs and it does a pretty good job. Well, that's because they consulted with Mark. Oh goodness, I just blanked on his name.
The CRDT kind of people.
Yeah. So they got that pretty good. But then I take a look. I was just using OneNote to try to do the same thing with a group of collaborators, and it immediately turns over and gives up and says, "Oh, can't sync this. You copy paste and make it happy." I was like, TreeDoc, it's a thing. Look it up, implement it.
Right.
So yeah, when every application is doing it their own different way, and some are going to be successful and some are not, that's because we're used to building databases on the inside, and our application is around it, and so synchronization of that database is a thing that the application designer is responsible for doing, and so they get it working on their machine and then say, oh yeah, I need to do this sync thing. Okay, let me get to a whiteboard and see how I can figure out how to make it work. Okay, that's good enough. Let's ship it. Versus if we were to turn that inside out and put that data on the outside, and then each personal application was participating in that substrate. That when I describe it like that, people think I'm talking about blockchain because blockchain works that way. But yeah, imagine that it's that kind of a shared data structure, but without the proof of work. It's all partially ordered, and so people can come and go and participate take their subsets, work with them, create their own facts, and distribute them on the substrate. Then you would have this pile of hard drives. It's just all of the data that you've accumulated over your lifetime, and then you could apply the old application or a new application and understand what that data means.
Right, like the very granular schemas of each fact are easier to kind of parse afterwards and make sense of. I did find that even with something like event sourcing, is that having granular schemas of events is easier to reinterpret later and adapt in creative ways than if you have just the current state schema, which could be very inflexible. You have to just kind of like delete half the tables and move the rows into new things. Whereas with events, it's like you can't really argue with an event. Like an event happened. It is what it is. You can't. Like for example, right now on a concrete kind of a commercial project I got going on, we had this idea of a questionnaire. A customer answers a questionnaire, like this question answered, this question answered. And we thought that customer would fill in one questionnaire, which would open them to a choice of multiple products at the end. But in fact, what turned out is the model shifted dramatically to say, oh no, actually every new product gets its own questionnaire. So it kind of flipped that each product has its own sort of a namespace of what questions are considered valid, because it has to do with like a medical diagnosis, and in a different context, questions are to be interpreted separately. So what was cool is that in an event sourcing kind of a context, what we did is we just sort of backported the idea that everything that was answered with the old questionnaire, implicitly that was for just this one product that we had in mind. So we just added like one little annotation, but that made all the old events understandable, and new events that are for different products are still understandable. But you didn't have to like, whereas in a traditional relational schema, you would have to like go to all the answers, flip their foreign key type from customer to product, which would have, you have to kind of go back and do a data migration. So, and long story short is I think like that's with events, but with facts, it's a similar spirit that if instead of a large schema with 10 tables and 12 columns each, you have several dozen of little schemas of just the sort of a minimal set of fields for the fact, and then time passes, business reinterprets itself, and you look back at those old records, the little schemas are still understandable. Yeah, and they have captured information that you didn't even think that was important, or know that you wanted captured. I mean, that was one of the most powerful things that I saw when I first started with event sourcing was being able to let's stand up a brand new report, a brand new set of analysis, and now we're going to run our stream of events through this stream analytics processor and come out with new insights that we didn't know that we were trying to capture before. And so the value of that history is just immeasurable. Wonderful.
Yeah. Besides all of the technical problems that it solves.
Understood. Yeah. Jan and Michael. Yeah, how has been applying historical modeling? Do you have like aside from Jinaga, do you have like commercial projects where you kind of do this, or just what's new in terms of kind of pushing this idea forward? Go ahead, Jan.
Yep. Well, I'm working on a project which involves mobile telephones. So what you was talking about just now, it's actually an application for a dispatcher who has to send tasks to service people, and who has all the facts, all what they have been doing, the working hours, the parts they have been using, transportation. All these facts have to come back to the dispatching for invoicing. So it's a complete mobile app connected, synced up with the Windows application for the dispatcher. I actually have that application, which I made a long time ago with the Microsoft Sync framework. So that was a database on every Android device, and then a server with a Sync framework with a SQL database. But it has a lot of problems. One of the problems is that synchronization with mutable data is very complicated. And on the practical side, the most difficult thing, if I have an update of my software, the only way, if it's a major update, is to say, okay, people, Friday evening, everybody make sure that all the data is synchronized, and then you stop the phones, you uninstall the app, you don't work for the weekend. Saturday evening, I will prepare the new software. Sunday morning, everybody downloads the new software, downloads the data again, and Monday morning you can all work. Because you have the schema on the server and you have the schema on the phones.
Yeah.
And the big advantage of historical modeling is that you're just passing messages.
Sure.
And so the server, the servers of the distributor, which is actually but one of the communication elements, is completely independent of the schema.
Right.
Yeah, there is no schema. And that makes updating a lot easier. So that's actually one of the main reasons that I'm working now with historical modeling.
Yeah, schema is a huge component of it. It reminds me a little bit of protocol buffers, the way they approach versioning of basically, there's a strong emphasis in that message format that you have to tolerate old fields forever. Like, because you never know where there might be a lingering old client with an old schema of the messaging or old software, and they might be passing through kind of, just need to understand the old messages. Yeah,
but everything has a limit. I don't see people these days connecting to the internet with Windows 95 computers.
For sure. I think in what is it called? A telemetry product I was working on once, so where we used a lot of protocol buffers. Basically the workflow has always been, you can never change a thing. You always have to go through a 2x2 of old receiver, new receiver, old sender, new sender, and you can never shortcut diagonally from old to new. You either have to update the receiver first to tolerate a new field in a message, and then update the sender to send that new field, or vice versa. You have the sender send the new thing, but the receiver just kind of manages to ignore it, and then you can delete the old thing. So it's like it's always a 2-3 step kind of a transition. Add the new thing, use the new thing, delete the old thing, like retire a field, or so to speak. Does that seem kind of how you would be evolving the schema?
Well, in a practical way, the purpose is that not everybody has to upgrade at the same time.
Exactly, yeah.
So of course, one user will upgrade today, another user will be on holiday, and he will upgrade in 3 weeks. Right. But that means that he might still have messages in the old format, which he has not been sent to the network. So of course, these messages have to be accepted because these are facts, things that happened but have not been synchronized. But somewhere you have to say, look, you cannot be longer than 1 year on holiday.
Right.
Yeah. Because anyway, data that has not been used for the whole year is probably not useful anymore.
Right.
The customers have been invoiced, the project have been finalized. But
This comes back to a kind of a variation on the period pattern.
Right, exactly.
Yeah.
Exactly. Yeah, so at some point you stop caring about old periods, and so if something shows up for them, you just won't see it. You won't do anything about it. But yeah, this. Go ahead.
Go ahead, Michael.
Okay. This concept of handling versioning, that's a problem that we've come up with several different strategies to solve. Even having these kinds of conversations in the past, we've talked about the all the way from a simple to a complete redo of the model. So starting on the simple side, as you evolve an application and you add new features, what you will tend to do is create new types of facts and not change the existing ones. The facts are immutable, so therefore that kind of implies the fact that the type of a specific fact is immutable too. That schema is not going to change because there it is. And so it's like, okay, I'm going to have this new feature. I need this new property that somebody can set. So okay, mutable property of this same entity, but that mutable property fact is a brand new type of fact. Or I've got a new step in my workflow. Okay, here's a new fact that represents that step having been taken. And so you tend to just increase the kinds of things you can put in the DAG, rather than change the things that are there in the normal course of building your application. And so having immutable runtimes that don't care about that schema. They can store a DAG, they can transmit subsets of a DAG in terms of facts. They can run a pipeline and figure out who's interested in what and just send them what they need. And so they continue to work according to just the generic abstract rules without knowing the schema, and you evolve your application that way. Now, that doesn't account for 100% of the application changes you might need to make. The insight that you just talked about earlier about a survey being related to a product and not just to a customer, that's one of those changes where you want to add a predecessor to a fact, and so that's that's a change to its fundamental schema. So the next strategy up that I usually employ during those types of changes is that the new type of fact, the new type of survey that is related to a product is a different fact type. And so that's where things like structural versioning come into play, where under the covers it can take the structure of what you're trying to say, what is the schema, and then compute a version number for that. And that way you can see, oh, this one was produced by an old version of the software, that one's produced by a new version of the software. And so your old software doesn't understand the new schema, and so therefore when a fact arrives at that software, then it just doesn't recognize that as a fact type that it knows about, and so it ignores it. And now it just doesn't participate in that new feature. But a new version of the software, the downside of this is that it has to understand both, and it has to continue to understand both for a long period of time. Ideally indefinitely, but eventually you'll say, okay, years have passed, I can clean up this old code. But
right. Nevertheless, a lot of emphasis on good naming, because changing a name of a property is really hard in these kind of schemes. Or harder. You have to tolerate the old name for a little while, which can cause confusion. Yeah.
And so keeping a clear distinction between the facts and the projections of those facts helps in that regard. So you can project some facts that you're not really happy with the the way that you designed them in the first place or the names you gave them, but you're going to project them into an object model that that makes sense and that you can then display to your users. And so you can update that projection any time that you want to, and just roll out new versions of the software, and it'll still interpret the old facts. And so I'll usually do that union of different schemas in that projection layer. So I'm going to query for this kind of fact according to this shape and that kind of fact according to that shape. Now I've got these two collections, and I run them through the projection. They now become two collections of the same kind of view model, and union them together and put them on the user interface.
Yeah, it's like a adapter.
Yeah.
You're adapting the old to the new. That makes sense.
Yeah, but then it goes to the extreme where you start to bring topology into the picture, and you do something like Jan was saying, is that well, maybe not a hard cutoff in time, but at least a hard cutoff in space. It's like all of the old system, old phones are going to be talking to this server, and it's going to translate into this this new model, and so that one topological choke point is going to do that transformation into a new model, and now this is a brand new network participating in the new model.
Interesting. Yeah, that makes sense. I have a question about the Janaga software. Like I glanced kind of at the documentation a bit. There's like a node server and a client component.
Mm-hmm.
Is there, because I think if this was hard to get over the typing into the Discord, but inside of either of them, there's a bunch of kind of shared code that has to do with just sort of managing and querying the DAG, like the chapter on query inversion and things like that. That's pretty dense, and that sounds like a tricky piece of code to get right. What I was curious about is that piece of logic available just in unnetworked form, where like if I just have a folder on disk full of facts, can I feed it into Janaga and start having like asking it questions like make queries, answer queries?
Well, okay, so the answer right now is no. But now you've got me thinking about how that could be. So, well, one thing that that you could do with the Janaga package as it is create a node application, and so you'd just be using the server-side components.
So start the server and then run something that feeds the facts into it one at a time.
Yeah.
And then send requests to the server to like query it basically. So it's just like just have the server do this, right?
Yeah. One thing that I'll often do in a Janaga application is I'll have an express route that goes to a function that runs j.query and then projects the results into a JSON structure and then just feeds it back. So now you've got a RESTful API that gives you the current state of the system, or could even if that projection doesn't care about current state, if that projection preserves all of the history, then it's actually a historical projection. So those will sometimes come in handy. If I'm doing an integration with with a third party, and so I want to just be able to grab some JSON data and then shove it into a system that wasn't designed for with immutability in mind. That works pretty well.
Got it. Okay, yeah. So it sounds like if I wanted to play around with some of the tooling related to these concepts, then the Janaga server sounds like a little bit more of what I'm looking for, because it's I think like some of the basic concept of just like structuring and serializing the facts I was able to kind of do, and it works, just storing them and then playing them through into memory, and now you have an array full of them. But I think it's at some point all the goodies that you have for efficiently querying collections of facts and grabbing all the predecessors and things like that, it sounds like the tooling here is very important. I
Yeah.
was curious. Actually, that brings me to a question. Have you thought of like, because in industry as a whole, this is a very kind of new kind of a pattern, and
Hmm.
like it's not exactly like as widespread as like Rails
Yeah.
database Go, right? Like it's the vocabulary isn't quite there, and so but you have this server client Jinaga software. Is have you thought of like considered like implementing this as like as a service, even though this is like extremely centralized as a concept, but
Hmm.
basically, you know, to just get access to historical modeling, like people would sign up on, a
Yeah.
janagaservice.com, and that gives them a API to put facts into and get queries out,
Hmm.
but following the historical modeling rules. Like I think that could be a like easy to try before you buy
Right.
kind of
Yeah.
experience.
Yes, indeed. Yeah, that is kind of part of the vision of what we're trying to build. So, um, so yeah, the Janaga package that you currently see officially now is called Janaga JS. Yeah, there's going to be a
Mm-hmm.
Janaga.net that's going to be, you know, um, uh, maybe a .NET host. I think at this point, yes, a .NET host and certainly a .NET client, and that's going to target Xamarin and it's going to target Blazor. Those are going to be
Mm-hmm.
kind of um, the integration points for that. But the reason I said maybe .NET Server is that I want you to be able to have clients of all different kinds talking to the same kind of server. So you should be able to stand up a
Mm-hmm.
server in Node using Janaga.js and then talk to it with Janaga.net as a client. But
Mm-hmm.
once you're in that ecosystem, there will be customers who will want to just go with a .NET client or a .NET server. Um, so yeah, that's kind of that's yeah, that part of the ecosystem. But you're talking about Janaga as a service, and so a couple of other things that I've started a project around, and um, not focusing too much my attention on that right now, but still pretty excited about is the factual workspace, or the factual what was
Mm-hmm.
the name I gave to it, but it's something you can just bring up in your browser, and you can start typing factual code, and then create these sets of facts, and then have it um, give you a way to create new facts, or create new instances of those facts. Save that data
Right.
into the system, the ether, wherever that happens to be. What that happens to be is a decision substrate just behind it. And so that decision
Mm-hmm.
substrate is something that I can offer software as a service. You could just sign up. You can start to use any of the Janaga client runtimes against it, or you could
Mm-hmm.
bring up the workspace and start to code against it. Ultimately, I see people who are familiar with and comfortable with Excel and can be productive
Mm-hmm.
in Excel. They should be able to take that same that same mindset at the very least, and apply it to starting to create these collaborative data structures within a decision substrate. And so, hey, let's just go ahead and I need to plan a conference. So let me go ahead and start collecting all of my speaker submissions in this thing. So I'm going to create facts that represent that. So rather than putting that into a spreadsheet and then working that spreadsheet and saying, okay, accept, decline, and then now we have to schedule the rooms and all that stuff. You do all that within the this workspace, and it's all on this decision substrate, and then you can build an application that now taps into that and starts to present that information to an end user, participate in the decision substrate. So yeah, I can see lots of different ways of shipping this product. So as a service, you can just go up to Azure or AWS, sign up, and now you've got your own
Mm-hmm.
decision substrate running. You can, go to janaga.com, sign up there, and get access to one. You can download a Docker image and deploy it to Kubernetes, and you've got decision substrate
Yep.
nodes running. So yeah, and then these should be able to connect with one another. So now that's really where that opens up the true power of this. Is now I've started building an application on my hardware or in my cloud, and I want you to participate. So I'm going to set up some security rules, authorization rules, distribution rules. Put that at the boundary, and now we can start to exchange facts. And so you've got your decision substrate
Right.
running and got them hooked together.
No, yeah, that's very interesting. It brings to mind, like for things that are more public, it kind of almost reminds me for this interactive kind of case. I think it's Stephen Wolfram. He's big into like what are they called? Notebooks,
Mm-hmm.
where it's like a mathematical code. It's like code and documentation kind of in a single sort of a file,
Mm-hmm.
and people run through it. Also, in London, I think there's this guy Jeremy Ruston. He does this thing called the Tiddly Wiki, where it's a wiki, but it's like he does some sort of a trick where it's an HTML file with a bunch of JavaScript in it, but when you're trying to save something in that user interface, it saves into the file itself. So it's like a self-modifying HTML file. Is the best I could put it. And then, but the advantage of that he cites is that then it's extremely shareable. You can just email it to people.
Oh,
put
okay,
it in
right.
Dropbox.
Yeah.
Put it in Dropbox, commit it to source control, that sort of thing. I think what you described, like for this, because the schema of facts that you come up, like the modeling of a problem, in itself is super useful,
Mhm.
right? So the idea here is you want to create a factual schema that say talks about conference planning, and you can send it to 3 people, and they can put different facts into it, and then share it like, okay, what if these facts? And what if these facts? And then you
Mhm.
look at both of them and say which one you like better, but the querying and the model is kind of the same in both of them. You
Yeah.
agree on the same model, much like with the way people share spreadsheets, right? Because
Mhm.
they share in the spreadsheet, all of the like interesting business rules are in the formulas.
Mhm.
And then the idea is you send a spreadsheet to someone and say, hey, here's a home mortgage calculator, put in your numbers, and it will tell you what to do or what it looks like. In your case, it's here's a factual workspace, as you call it.
Mhm.
Here's like a thing. Put your facts into it, and something interesting is going to come out.
Yeah. Yeah. Exactly. Yeah, and
Okay,
with
that's interesting.
just the factual language and some basic tools, you can get just kind of the Excel experience. But then you write code on top of that, and now you've got a full a rich user interface for your application, and you should be able to make that step whenever it's appropriate to you. Like as a conference organizer,
Right.
I might just do everything inside of the factual workspace, and then I'll be comfortable with that, and then give my my attendees a mobile app that's written in React Native or something.
Right. Yeah. Well, yeah, and even as a planner, like because it's hard to write facts by hand, like
Yeah.
typing them out, so to speak. So you need some sort of an interface to, once a schema is defined, maybe it's just like a quick form add.
Yep. Yeah. In fact, writing facts by hand was something that that I used to do as part of my early Janaga talks. Just bring up the browser, and it's like, okay, I've got the application running up here, but then down here inside of the console window, I'm going to type j.fact and this JSON object, and watch, boom, it appears on the user interface.
Oh, it still makes sense, right? Because
Uh-huh.
it explains that the model advances one fact at a time.
Yeah.
Very interesting.
Yeah. But speaking about conference talks about Janaga, we've got one coming up on Tuesday, and so Jan and I have been collaborating on the sample application for that conference talk. And so yeah, you just submitted a PR for that next feature of
For the
showing the completed items.
it was just a small change. It helped me a lot to understand the mapping, which I didn't really looked into before for React. Specifications, the mapping, the containers, and by doing that and having the sample, that became clear.
Excellent. Well, that
Before it
proves the idea of that being a good example application.
Yeah. Because perhaps I was thinking, Michael, probably you will use that application in a later stage as a kind of tutorial. Not have the whole Git at once, but to make, for example, step by step, each step a branch.
Yeah, I like that
Step
idea.
number 1 branch, step number 2. Because if you see the whole thing in its totality, if we add authorization rules, if we add more user interface, if we add the shared model, it will be too complicated to step in.
Right.
Because it's easy, but to start from zero, it's not that easy, I think. So I think we should start with a step 1, very basic, and add on.
Yeah, I really like that idea. And so
If you go, I'm a bit out of context here, but if you're going for popularizing something, people I think really like the follow along tutorials where it really starts with the basics, but then walks through like a single commit worth of changes to kind of introduce a new feature. Ryan Bates for Ruby on Rails used to do this phenomenally. He had this thing called Rails casts,
I'm gonna have
where
to look at those.
he would always begin an episode with like, here's a sort of a hello world like Rails application that everyone will recognize, and then he walks you through, let's add a new model, let's add a new controller, let's add a new this. But it was like a real change, but it was bite-size interpretable, and sometimes the episodes would chain together where it's like, okay, last time we added this, if you haven't seen that, please go there, and now we're going to build on that to add something else. So it sounds like what you're describing with branches is a little bit of a similar spirit.
Yeah. So yeah, the thing that we've been kind of working on building up to this conference talk is putting together steps. So this excuse me, documentation out on janaga.com starts with the big concepts, but then we've got steps, and these are intended to be commit-sized steps. So yeah, that's just npm install. But yeah, here's some tests that you can write. So you just get those in there. You can configure Webpack. So kind of a bigger step because hey, Webpack. But yeah, that's precisely what we're shooting for here. The idea being that you should be able to just look at these steps and figure out which ones are important to you. Like, I use Webpack, but I'm using JavaScript, or so yeah, a lot of these are JavaScript, TypeScript. But here I'm not using Webpack at all. I'm using Require.js. I'm going to have another step here for create React app. That's going to be probably belongs in React steps, but you will do that instead of these. So still haven't figured out where that's going to go. But yeah, I would love to continue these steps with the example application. So so now you are writing authorization rules for this particular application. You're mapping mapping a projection to a React component.
Mm-hmm.
Yeah. So
Yeah, looks really cool. I'm a bit short on time. I'm gonna run
Yeah.
soon, but just wanted to say a big thank you for the book and for being so responsive in the Discord. I think it's a super interesting idea. Like not and I've been sharing the book with a lot of friends and old colleagues, like saying, hey, all that immutability stuff we used to talk about. Well, this guy here takes it further than we tried with the different approach to sort of putting time into the software, because in some respects it's a hot topic right now with I mean within certain crowds. It's a niche thing. Like I think closurists sometimes talk about time, kind of explicit time in their facts, but yeah, it's very exciting. Thank you for writing it.
cool. Yeah. Thanks for sharing and thanks for joining in.
Yeah, good to meet
Appreciate
you,
it.
Jan. Thank you for your explanation as well. I'll try to
Well,
make some of these discords and tell folk about it.
I'm just the user. It's Michael who is the mind behind it. Michael, if I understand well, from next week onwards, it will be on Monday evening, eh?
That's correct. Yes. Yep. So
Okay. Oh,
same
Sergei
time.
is already gone.
Yeah.
Okay. No, not a problem for me. Very short about the application for Java Friends, or JavaScript and Friends. I don't have a lot of time to Monday now, because I'm moving back to my office, and there's a lot of work waiting for me there. But what should be done? I think the CSS type of stuff to make it look nicer.
Yeah, honestly, I think the what you've done so far with validating steps, validating the the code, and then adding that that feature, that helps me to that gives me confidence that yes, other people will be able to pick up this example application. They'll be able to understand the concepts. We'll be able to apply those concepts and do something new with them. So so yeah, as far as making it look like a more complete application, I think that's at least going into this conference talk. I'll let it look very vanilla.
Okay.
Yeah, not try to to make the CSS really pretty. Yeah, so I did do just enough. Excuse me, just enough layout to to put the labels on the checkboxes, so it doesn't just look wonky, but
Yeah.
but yeah, I think that's sufficient, and that way the application can stay out of the way of the message of what's
because otherwise
different and what's
it
special
will-
about this. Yeah.
Yeah, otherwise it will confuse people if we add too many things directly.
Right. Yeah.
But I think it might be a very nice app in the future just to train people. For example, a next step could be now we have a completed list, and we could allow people in the completed list to decomplete things, to bring them back to life.
Yep.
So just a restore fact, and that in a tutorial form might be very useful. But okay. It was
Indeed.
for me. It was very helpful. So I think for other people, it will be helpful. If I understand it, other people will also understand it. So-
Excellent. Yeah. You can't know how happy I was to see that PR, and it's like, oh look, he did it, and it's just the simplest changes necessary to make it work, and it's so changing the the predicate from not completed to completed, then using j.not is like, okay, yep, that flows, that makes that understandable.
No, I don't have the fluency yet, but with the example of the normal list, it was not that too difficult to make the completed list. Actually, just a copy of it and another query. That's all, specification function. But it really helps to understand. So I think I was more happy that it worked than you were to see it. Okay. I'm not gonna take more of your time, Michael. If there is anything I can do, let me know. If I have some time, I'm gonna keep exercising with that app.
Cool. Excellent.
Because it teaches me how it goes.
Yeah.
The conference is, I think, the night from Monday to Tuesday. I think in.
Yeah. Let me see if I can.
It's after the meeting anyway.
Yes.
Yeah.
That
Okay.
That is correct.
Okay. Anyway, that will be in English, because the Polish one was a little bit sad that only your portion was in English, and even their website to subscribe was difficult. I needed Google Translate to help me. But it was a very interesting talk.
Excellent. Yeah. That's the one I want to refine a little bit more and start to shop, because it does go more specifically into the topics in the book, whereas my other talks are more about so hey, you use SQL Server, let me teach you how to do that in a different way. This is well, it does start with the hey, you're using Kubernetes, let me show you how to apply a pattern to it, but that's the only thing that it presupposes. So it's able to really talk about the patterns of historical modeling and then tie them back to Kubernetes.
And I think somewhere in the future we should also build a small example app for that, because one of the people was asking, do you have something practical? And there was no real implementation. But if you could just show something, two databases that you synchronize, one SQL Server, one Postgres. That's something that people see, and then they say, oh, it works.
Yeah, exactly. Yeah, and that is
All right.
Is a lot of.
I'm not gonna.
Yeah, you have to read the book and understand these patterns, and then you apply the patterns in your application, and then hey, it works. It'd be nice to have something that's come out of the box.
Yeah, because I think for people who hear it for the first time, it's complicated. Because I'm getting used to it through the years, but I can imagine if you hear it for the first time, 1 hour, it's not enough.
Yep.
Okay.
Yeah. Okay. Yeah. So the
Michael, thank
the
you
talk
very
is
much.
At 2200 UTC. So I guess that would be midnight.
Just midnight for me.
Yeah.
But I will be there, no problem.
Well, I appreciate that. Sir.
Okay. Anyway, see you Monday at 18 hours UTC, I think.
Yes, indeed.
Okay.
Right.
Have a good evening. Bye-bye.
Bye.